Uh, hey everyone, my name is Nishchay, and I'll be talking about how CWLApp uses Parsl to integrate a common workflow language. Next slide. CWL or common workflow language standardizes describing your workflows, and CWL app using Parsel's Bash app will help you create workflows by bunching together a few command line tools. And next slide. So here's the quick overview for CWL. So it's a standard that describes how to run command line tools and connect them together to uh, create workflows, and it simplifies writing and expressing different workflows. Next slide. So a CWL file can either be a workflow or a command line tool. So in this presentation, we'll look at command line tools only, and how CWL app, using CWL app, we can bunch together a few command line tools to create our own workflows. Next slide. So here's an example for the command line, a CWL for the touch command, and the CWL file would include the CWL version, and the class would specify if it's a command line tool or a workflow, and the base command would be the base command, and the inputs to the command line tool would be uh, mentioned under the input section, and the output section will contain stood out, stood error, and if any output files generated during the command execution would be specified here. So within the input section, the touch command takes a list of file names as input. So the file names input argument here would specify that, and the type here would the type is to mention what kind of arguments is this, is it specific for this particular input argument. So file names would be a list of file names, which would be a list of strings. So the list of string uh, type would be specified here, and the different input bindings necessary for each input argument are specified under the input binding section. So here the position 1 would mean that file names would be the first argument after the base command, and separate by default is true, but it specifies that each it's a list of files, and each value in the file in the list would be separated by a space. So that's what the separate keyword here specifies. Next slide. So to create the CWL app for the touch CWL file, the CWL app requires you to provide the path to the CWL file, and to invoke it, we first need to set the input and output arguments like we have specified in the CWL. So we have to make sure the Python function argument names are the exact same as the ones mentioned in the .cwl YAML file. So, and like for internally, so calls to CWL app would invoke uh, Parsel's bash app. So any output files created during the command execution would need to be specified with using the Parsl file object command. And uh, if sometimes if the from the Python function call, if it's unclear what the exact command that will be executed, we can always use the command template attribute of the CWLApp to just get an overview of the template that for the command that will be executed. Next slide. So here's a more complex CWL for the find command. Input input arguments can have default values, and the arguments can themselves be optional as well. So if the arguments have default values, they are mentioned with the default keyword, and if the input args are optional, they are specified using the question mark uh, at the end of the type. And so prefixes here would indicate if within the command that's executed, a prefix is necessary for this particular input argument. Uh, Similarly, stood out and stood error are specified within the output section. So one a command that can be generated, that might be generated using this CWL file, would look something like this at the bottom. So find followed by the path where the find um, starts searching, and then name has a prefix with hyphen name. So what the input value that is mentioned will always be prefixed with hyphen name, and similarly max depth, if specified, will have the hyphen max depth uh, prefix before it. Next slide. So the calls to find command using the CWLApp, so we can include the directory uh, dir option for it. So the if mentioned, this will show up in the command to be executed. Similarly with max depth, in the second uh, Python snippet, I've excluded directory and max depth, which would mean that for directory, since it has a default value specified in the command line in the CWL file, the default value would be used, and max depth is an optional argument, so that would be omitted from the command. Next slide. So here I have an example of a toy example of how we can combine different CWL apps to create workflows. Uh, let's say I have all the CWL apps created under tools. So here using the cat, the first call to cat command, we are combining three different files into one combined .txt file. And like I said before, calls to the CWL apps will invoke Parsl's bash app. So the cat feature would be an app feature that the bash app returns, and within the app feature, the outputs attribute will have data features for each file that was created during the execution of the command. So we get the data feature for the combine.txt from the from cat's app feature, and then we can use that within the word count CWL app or the command line tool in the second part of the code. So uh, yeah, so we just forward the app the data feature from the first command to word count and then get the result. And at the end here, we're just printing stood out for the word count command. Next slide. Similar to the last example, here we are using three different cat commands. So the first cat command would combine reports from the different months in Q1 to generate a singular Q1 report, and the second call to cat command is generating a Q2 report. And the third call would we are using the data futures from calls to each cat command from before and generating a combined half yearly report. So these these I have these two toy examples to show how we can use CWL and CWL apps to combine different uh, either dif either different CWL apps, and since each CWL app will behave similar to the bash app, we can combine any Parsls app along with the other CWL apps to create more complex workflows as well. And yeah, next slide. So yeah, so the links to know more about CWL and the doc and more examples for CWL app are under Parsl's GitHub under CWL Parsl. That's it from me. Thank you.
Thank you, Nishchay. Does anyone have any questions about Nishchay's work?
I guess one thing to add, big motivation for us here was that we were interested in supporting more bio workflows, and a lot of bio tools. There's been a big effort in CWL to go and wrap bio tools with CWL definitions. So this, by integrating it, provides us access to a large number of tools that have already been, people have gone through the effort of describing the interface input and output.
I just have a quick question, Nishchay. Have you tried running like a large workflow that is composed of these imported like apps? Like what did you run into any issues? Do you see any bits that just don't work well? I'm curious about like what your experience was trying to use the imported apps to do something more real.
So I've not really tried it with any large workflows as of yet. So, but with the few examples that I did try with, everything seemed to work as expected.
Okay.
Yeah.
Would you expect it to be any different, Yato? It's just a command line invocation.
I think so. It's just more of like the UI weirdnesses that I'm like curious about. Like, did something look awkward? Would you change anything? I'm just curious about what you think.
One caveat with getting things out of std out was that you will have to stall execution there, since the command output executed will be within the app, and then the next app needs whatever's already written within the app. So we will have to manually using Python open and read the app and then forward the outputs of the first command in certain workflows, I guess.
Oh, I see. So this is basically because wait, so the std out is wrapped inside the future from the app, but the std out is not treated as a future, just like an output is. Is that the weirdness?
Yeah, so whenever we needed std out, so CWL does allow you to specify more input arguments so that you can forward it into another file within the command itself. So you would need to add the forwarding and then specify that a new file would be created, and then that file would act as a data future.
I see. Okay.